Welcome everyone to another observability clinic. It's a community episode, Dynatrace community practices number 11 already. Today it's best practices on Dynatrace DQL time series, which is exciting because we can now also query time series data with DQL. I always bring experts in and people that use this on a day-to-day basis. Ajay, thank you for doing this. How are you?
Good. Hey, Andy. Nice. Thank you for having me. Yes. So now that we got metrics on DQL, let's figure out how to then query those metrics.
Yeah.
So looking at what we're going to do today, introduce ourselves to the time series command within the DQL. It's a very specific command to query metrics. Now that we have the power of the query language, we have the ability to now gather information, data across the topology mapping, across logs, across events, so we can gather and create unified views of all those data sets.
Mm-hmm.
Conditionalize. Now in the query itself, you can add additional fields, and those fields could be conditions where you're checking to see a certain metric and you're making sure that metric is not above or below a certain value, and then create a column or a field that then indicates whether or not you've breached certain conditions.
Mm-hmm.
And then finally, different ways to visualize based on how you configure the query itself.
Mm-hmm. Really cool. And actually, just for everyone, because we discussed this before recording this, we assume that people have a basic understanding of DQL, the Dynatrace query language. In case this is new for you, check the description of the video. We will link to other resources, other videos we've done on DQL, the Dynatrace query language, also DPL, the Dynatrace parsing, our pattern language. We have documentation. So today is really focusing on time series, but if you are new to DQL and want to learn more, there's so much existing content already out there. But this is really exciting, especially we will see the lookup command, we'll see time series, the conditional formatting is also awesome. I mean, this is something I've seen so many people now do because it really makes your notebooks and dashboards so much easier to then consume and look at. But yeah, take it away. Excited to see more.
Yeah, exactly. Obviously, we're using DQL, so you'll learn a little bit about the formatting and the syntax. But yes, there's quite a lot of content that we put out for DQL. Looking at the time series command, this is going to be one of the basic time series command. It will contain these parameters. First, you have the query the metric that you are querying. This is going to be an aggregated metric, so you apply an aggregation on the metric. You will then have the ability to filter the properties of that metric. In this case, we have a Kubernetes pods count metric where that metric has a dimension cluster name. So we're looking at a very specific Kubernetes cluster and filtering the metric on that cluster. Mm-hmm. We have the ability in the query to set our intervals as well as our time frame, and then the ability to split by dimensions. Mm-hmm. So all this is baked into a single command. There's no in terms of the DQL where you're querying logs or events, these would all be separated into different commands. With metrics, it's all in the time series command. And I guess it's good to know that about 70 or 80% of metrics are currently supported on Grail, focused more on the infrastructure metrics as well as cloud metrics with services and applications to come. Mm-hmm. Now looking at metrics on Grail, what has changed from the classic? We see that metric keys have changed to make it a little bit more easier to understand what the metric is. You see on the left here, we've had this syntax in the past where we have the built-in colon, typically the entity and then the metric, and then some additional information about the metric. That has now been moved to DT dot the entity and then the metric. And then we've moved over from camel case to all lowercase, any spaces separated by an underscore. It's easier to read, easier to understand.
Yeah, I agree with you here, and especially thanks for that comparison, because a lot of us are used to using the classical metric keys and the metric selector. While it was
Yes.
also for me, it was like we got used to it, but I think the new way, the new keys are much more straightforward. Yeah.
Yep. So it's good to know that they've migrated over to this new syntax, because if you're in the query language and you're trying to query metric, make sure that you're using the new metric keys. And then the scalability. So because of Grail's scale, we've been able to compact multiple metrics into a single metric. Here we have an example where we have two separate distinct metrics that have been migrated into a single metric. We have the network bytes, NIC bytes, that's all been moved over to a single metric on Grail. So you'll find this with a couple of the other metrics as well. So if you're seeing that you're missing a metric, it's probably been migrated into a second or a single key for you. And that's all because of the scalability of Grail. So that's time series. Now let's take a look at some of the power behind what we can do with DQL as it relates to metrics. First, starting with contextualizing. So this is kind of where we utilize the lookup function, which results in a single row of a separate data set based on a condition. So in this case, we are going to start by querying the cloud application instances, which is a application that's deployed to Kubernetes. Then we're going to query all the events that have happened on that on that application. Finally, we're going to look at the time series metrics for the processes that run that cloud application. And then we're also going to look at the logs on in this case, underlying host on that application or on that Kubernetes node. So we're able to, with a single command, have the context of the events, metrics, logs of every entity within that topology mapping of a given source, and then present you with a summarized view of the data set. This allows us to do quite a lot of things to understand the root cause of potentially a underlying component of your application, to understand if there's logs that happen in this area, what happens to the metrics that result on the process or the underlying service. So there's a lot of possibilities now that you can contextualize metrics, logs, and events.
And I think this is just what I wanted to add to this. When we launched Grail last year, we talked just a lot about logs, but now seeing this really fulfilling on the promise of getting all of your observability data into Grail and putting them in context to the relationship that these entities have with each other. This is just amazing, because as you see here, you're focusing on a particular workload on Kubernetes and then walking up and down the dependency tree and getting your events, your metrics, and your logs depending on that entity. And this is just powerful. So folks, we will also add a link to the lookup function in Grail to the description, because this is really powerful.
Yep. Now looking at conditionalizing. So this, the fields add command in a DQL gives us the ability to add an additional field in our query. That additional field can be a condition. It can given a metric, right? In this case, we are querying the container memory usage. This would be your typical use case currently, as well as in Classic, where you query the metric and you get your average. There's not much more that you're gaining from this, right? You have to now go and see if it's normal to have a 94% percent memory usage. Now within DQL, you can add this fields add command, which then you can put a condition on the metric you've queried, and then based on the results, either you can result in a emoticon like this, where it's a warning, or a check marks, and seeing that very easily tells you that there is something that we should further analyze in this metric here. It gives any user that's now looking at a dashboard or a notebook a very quick context as to what may be happening within their workloads. So this is a good example of using the field adds to add more context to the metrics that you've queried. Looking at visualization with regards to dashboards and notebooks, there's 3 kind of distinct ways to visualize your data. This is either using the categorical, pie chart, donut chart, or single value. When you're looking at the time series command, if you add a field command at the end, this will give you the options to choose any one of these charts. The line chart, area chart, bar chart, and single value without the use of any field command. If you simply do the time series and summarize, you will then be presented with these options. And then there's the band chart. If in your time series you use a combination of average, max, and min aggregations on the same metric, you're presented with the ability to choose the band chart.
Cool.
So understanding how to get each of these visualizations to appear for you is based on the way you syntax your DQL.
Awesome.
I think that should do it for the presentation. So I did put together a dashboard to help visualize some of the different queries and the resulting tile itself. So yes, we have the basic time series command where we have an aggregation, a filter, some evaluation timeframes, and then some dimension splitting. So these both of these tiles are using that same condition there. If we look at the query itself, I guess here I added the fields command, but here you can see the time series. First, we're aggregating the metric. We're applying the filter, evaluation time frame, and then splitting by a certain condition here. Let me see. I think in this case, so I purposely chose to add fields here. I do show this below, but when we look at the visualization, you'll find those same 4 visualizations that show up when you add the fields command or the summarize here. As regarding this tile here where we don't have the fields, looking at the visualizations, we see the line, area, bar, and table results. And we'll talk about that a little bit more in all the additional visualization that's possible based on the syntax. This one's looking at the context. So in this scenario, we are looking across a bunch of workloads, looking at the CPU metric as well as problems. Has any problems been open for this workload? If there's been problems, are there any logs that have error as the log level? And then how many times has that happened in this period of time is what we've presented with you here. Looking at the query for this one, again, it's going to be a little bit more more in terms of lines as well as the complexity here. We're looking at using the lookup function, right? We have 3 different lookups for metrics, logs, and I start with the events. So in this case, we have the entity that we're querying. The way or there's different kind of ways to approach doing the context. Sometimes you can start directly with the entity. You can start with the thing you care about most, or the one that happens most frequently first. There's different kind of ways to start. I could easily copy the entity filter and swap it out with the events, and it will still work. It just the lookup time could take, depending on how you organize the query, it will take the complexity of it will determine how fast this will then get resulted to your dashboard here.
I think also, Archie, if I understand this correctly, then your use case here is you want to find those processes that had a problem and then get additional information about are there any error logs and how many. So in your case, your approach is actually perfect because you say, first, let's look at all the problems, and
Yep.
then for those entities, for those affected entities, get me the additional information like the log level. The other way around, what you explained is, give me all of the processes and then look at in which ones have problems, assuming that you only have a very small number of processes that actually have problems. I think the way you solve the problem here is actually much better because you say, hey, I start with the data set that is probably much smaller in size.
Yes.
And then get additional information. So it's perfect. It's great that you did it that way.
Yeah, so there's definitely different ways to do it. There's better ways, and then there's ways that I think that's a good way to put it. The first thing that you should start with is which of the data sets will have the least amount of data. And obviously, problems will be the least amount of data based on my use case here.
Yeah.
Moving into conditionals. So again, the ability to add a field that then is going to provide us with some more information about this metric, right? It's good to visualize the metric itself, but to also have some more informational and context here, give us as a user of this dashboard some ideas as to maybe what's going on, and looking at the query itself. In this case, I query both memory and CPU usage. So I have a time series for the memory and then a lookup looking at the CPU for the same container group. I then, towards the end here, add the two fields that represent these two columns. The first one being memory average. I added a variable to this dashboard, so I can say I actually care when the memory usage is only above 80. So if we look at this dashboard here, we see now the only, what was it, CPU or the memory is what I'm looking at. So now if I reorder the memory descending, we can see only the 91 and the 82 are actually resulting in our exclamation point here. So we can use the dashboard to functionally filter this dashboard in terms of the conditions here.
That's a great usage of variables too, because so far I've only seen variables typically being used in filters. Like, filter, I want to see data for my Kubernetes cluster and then pick the Kubernetes cluster on top. But you actually showed how to use filters also for conditional, for your thresholds, basically.
Yeah, exactly. So you can have different time periods might need different thresholds, and you can quickly change those by using a variable like this. Any other thoughts on kind of use cases of conditions like this?
The only thing that comes to mind is that obviously you are showing here to show the value and then the icon in a separate column. You could obviously combine it. That means you could show the actual value next to the icon and then even remove one of the columns because then it's kind of duplicated. Other than that, what I like is what I would like to see, and just correct me if I'm wrong, not sure if that's already working. It seems we're allowing emojis here. Are we also allowing maybe links? Can we also create links that then would get people, if it's red, then I can click on it and then it gets me somewhere else, just like intents. That would be also interesting.
I'm not sure if it'll be a clickable link, but I imagine you could add the link here. You could add a a markdown tile that
Markdown tile, yeah.
also has the conditions and
Mhm.
then resulting link as well that's clickable.
Mhm.
Yeah,
That's
I'm sure
awesome.
it's definitely possible. Yeah.
Yeah, yeah. That's really awesome. It's really, really cool stuff. And then, combining this with what you had above with show me my components that have the biggest problems, and then give me an immediate indicator how severe that problem is, right? Are there critical error logs? Are there people impacted? Are there SLOs impacted? You can query all of this data now through DQL and really give you the view that you need as you're responding to issues or as you're analyzing your data. Yeah.
Yeah.
That's
Well,
fantastic.
dashboards and notebooks have become much more functional than
Yeah.
before. Not only do they visualize the data, but now you functionally can
Mhm.
apply conditions, context within the dashboards.
Exactly. Yeah.
And then moving into the visualization, again, there's going to be three different areas or visualizations, being categorical, pie chart, donut chart, single value, when the field or summarize command is utilized, line area bar when you simply don't utilize a field command or the summarize, and then there's the band chart when you use a combination of average, max, and min.
Mhm.
Again, what's different between these queries is the first one being, here we have a field command. This is saying I want these two fields and then visualize them in one of those options, right? We have the average number of pods per namespace, and then this is going to visualize those two properties, right? When you think about a pie chart or a graphical bar chart, it's not going to be multiple fields. It's always going to be two fields, one being the actual value and then one being the dimension that you're visualizing. In the line chart, we do not have the field, so this is going to be your default options without using any fields in your time series command. And again, we can quickly switch between the different visualizations here. And then this one's a little bit more unique in that we have two aggregations of the same metric being applied, in this case, max and min. So that then tells us at any period in this time frame, there was 1 to 3 pods across this cluster here at any one time. So that's how the band works. You have two different aggregations. It's always going to be either the min or the average, and then the max, which then gives you a period of or a range of metrics or resulting values where that data set could have been.
Now that's hugely interesting because especially if you analyze kind of an I can even think about transactional behavior, meaning do you have what's your throughput or response times is a good example too. Like, what's your variance of response time of a certain transaction? Or one of the examples that I do like a lot is to analyze, let's say, how many database calls do you actually execute per transaction? And then sometimes you have outliers because all of a sudden somebody comes in with an intensive query that is making many database calls. So now you can nicely draw this band and say, on average, your transaction is executing 5 database calls. The min is 1, but then you have some outliers that really go all the way up, and you can really nicely see how these things, you can spot your anomalies visually. Very nice.
Yeah, exactly. Yeah, so
cool.
I think that does it for what I wanted to show today. Again,
Yeah.
the time series command is how you're going to query metrics on Grail. And I identified these 3 areas where the time series command can be very powerful. First, applying context, right? With Grail, now we have all our data sets in one place where we can now context across the topology and data sets to provide us more contextualized resulting views like we have here, where we can quickly check to see the number of problems, check to see if there's any errors in logs, and has that impacted any key metrics.
Mm-hmm.
The conditions, again, applying functional properties to dashboards and notebooks where we can now visually, without needing to do any additional analysis, see the impact of the conditions that we apply to our metrics. And then the different ways to visualize those said data sets. Yep.
Perfect. Archie, thank you so much for this great tips and tricks, especially just showing people on things that are new now with the time series comment on what's possible. There will be additional sessions we will record. We will have the product management team also on in a regular observability clinic to talk about the time series comment in more detail. But this was a great community tip and trip, and I know you're constantly working with our users out there on a day-to-day basis, and there's a lot of things that you always come up with what actually helps people on the day-to-day. So I'm pretty sure we'll have more of these sessions with you. But for today,
oh, of course, yeah.
For today, I want to say thank you. Thanks for doing this, especially that early in the morning for you. Have a great rest of the day, and everybody else, watch the video, check out the links on the bottom. And also, in case you have tips and tricks, just let us know.
Yeah, thank you. Thank you, Andy, for having me. Yeah.
Always.
Bye.
Bye-bye.